we will see the bonding of NO2 molecule. This is a very special case. We have actually seen about the VB theory and about the VSEPR theory. So from the VSEPR theory, there is an odd electron on the nitrogen and the structure is bent, which we have seen earlier. And from the VB theory, what we say is it is having a sp2 type hybridization. So there is resonance in this molecule and odd electron is present on nitrogen, and this is also having a bent structure. And when we come to the MO theory, we will just look at how the molecular orbital are formed here. So the odd electron is present either on nitrogen or oxygen. So this is the major difference between the previous two theories, and this also predict it is having the bent structure. So what is the conclusion? Can we say what is the actual structure of NO2 with precisely? So this is actually a curious case about NO2. As we have seen the comparison of the three previous theories, the VSEPR theory, VB theory and MO theory, the structure of NO2 is quite interesting, and of course all the three theories produce that NO2 is a bent structure, which is common amongst all the theories. But the only thing which is having a problem is, where does that odd electron reside? Whether it is on the nitrogen as mentioned by the VSEPR and VB theory, or on nitrogen and oxygen as per MO theory. So this is actually quite inconclusive because experimental and the calculated values are always contradicting each other. The reason is like if you look at this arrangement, this is having actually a low energy. So in other words, we can actually say the electron, the odd electron present on oxygen is having lower energy compared to the odd electron kept on the nitrogen. So this is what theoretical calculations actually show, but experimental evidences are not very clear. Say for example, the odd electron on nitrogen more than on nitrogen on oxygen is given by these experimental evidences. The photoelectron spectroscopy shows that the odd electron is present on nitrogen and not on oxygen. And theoretical calculation also predict the same. The electron spin resonance shows sigma rather than the pi orbitals where actually the electron is kept. And of course, the most crucial thing is N2O4 formed from the NO2 has actually N-N bond. So if the odd electron is kept on oxygen, how a N-N bond can be formed? So this is also another evidence which tells that the odd electron is kept on nitrogen. But there are other evidences, say for example, the spectrophotometric and magnetic data shows that the odd electron is actually present more on oxygen and not on nitrogen. So this is quite confusing to find out whether the odd electron is present on nitrogen or on oxygen. So here are the examples of oxygen molecule formation. So here atomic orbitals of oxygen, that is 2s and 2p atomic orbitals of two oxygen atoms combine to form oxygen molecule as shown here. In this particular case, there is no sp mixing, so we have sigma 2p as the low energy followed by pi 2p, and two single electrons are kept in the pi star 2p orbital. So this is the molecular orbital diagram for oxygen molecule. When we extend the same to the nitrogen NO2 molecule, so the two orbitals are coming from oxygen molecule and nitrogen as a individual atom. So this is much more complicated than what we can actually handle at our level, that is at the BSc level. So you don't have to worry too much about how the electrons are placed and other things. The only thing what you have to say is there is one odd electron that is kept in the pi star antibonding orbital, and whether it is kept on nitrogen or oxygen, that is not clear. So MO theory clearly tells that there is one odd electron in the pi star antibonding orbital. So this is how NO2 structure can be explained based on MO theory in a much simpler way. So finally the question is, what is the actual structure of NO2? a basic level answer may be something like the bent structure with odd electron on nitrogen, because N2O4 formation can be explained very easily based on this. But at an advanced level answer is actually more experimental, and computational studies are required to confirm the actual structure. So you don't have to worry about too much about the NO2 structure. The simplest thing is NO2 has an odd electron, so that is enough. And most probably the odd electron is found on nitrogen at larger time. That means maximum number of time the odd electron can be present on nitrogen, and all the three theories provide that it is having the bent structure. So with that we can actually conclude the complexity of NO2 structure.